Lightning. Static electricity in its most spectacular form, slicing through the air as fast as 100,000 miles a second. Each bolt containing hundreds of millions of volts and peak temperatures of 55,000 degrees Fahrenheit. Lightning is capable of destroying property and threatening lives. Each downward stroke of lightning is an immense discharge of static electricity from a thundercloud where it has built up into the earth below. Drag your shoes along a carpet. Now you become the thundercloud. Your scuffing pulls electrons from the fabric, giving you an electrostatic charge. Reach for a metal doorknob. It, like the earth under a thundercloud, is a conductor, ready and willing to dissipate the charge you've built up. So when you get close enough, zap, the excess electrons stream to the knob in a miniature bolt. This static electricity, which we generate and which we can see and feel, lasts for only a fraction of a second and contains anywhere from about 2,000 volts, the lowest level we can feel, to over 25,000 volts. But below 2,000 volts lurks static electricity, which we and many common objects around us generate all the time. As small as 20 volts and far below our sense of touch, these static zaps are capable of damaging or destroying the sensitive electronic components we handle every day. This transfer of static electricity, whether visible to us or not, is called electrostatic discharge, or ESD. So what exactly causes the static electricity which produces ESD? As we just saw, two objects rubbing together can cause it. As the shoes rub the carpet, electrons transfer from the carpet to the shoes and to your body, giving you a negative charge represented by the circles with minus signs. This positive or negative charging occurs because the objects are made of different materials, each with a different tendency to gain or lose electrons. This list shows the tendency or potential of an object to pick up a positive or negative charge. The further away from one another two items are on the list, the greater the potential for charging, each in their own direction. So, in the case of rubber-soled shoes rubbing against a nylon carpet, the shoes and you pick up excess electrons, giving you a negative charge, which we can see on this meter. At the same time, the carpet loses electrons and becomes positively charged. Now your body's voltage is raised. That voltage will want to travel to any conductive object. So when you touch the doorknob, you draw a spark. That's ESD. Static electricity can also be caused when two pieces of the same material are in contact and then are separated. This is especially true with common plastics. Note how these two pieces of tape repel each other. They both have a similar charge and are capable of producing ESD. So what's the effect of ESD in your workplace? Well, while the doorknob may not mind the spark, the passage of ESD through an electronic device, such as an integrated circuit, can cause catastrophic internal damage to that component, turning it into scrap. The tiny circuit paths in these sensitive devices can be burned up or severed by an ESD voltage so small that our human sense of touch cannot even detect it. Remember, we can only feel discharges above about 2,000 volts, but some ESD-sensitive components can be damaged by contact with as little as 20 volts. You'll never know that the damage has occurred, but deep inside the device, destruction such as this will have happened. In these electron microscope photographs, you can see how a static zap has actually melted the silicon inside this integrated circuit. This damage is hundreds of times smaller than the width of a single human hair, but has turned this IC into scrap. And even when the device is placed on a printed board, it's still not safe. It can be damaged by a discharge that passes through the board's conductive pattern to the ESD-sensitive component. The amount of voltage needed to cripple or destroy varies from component to component, but as these devices grow smaller and smaller, their sensitivity to ESD increases. Sometimes the damage caused by ESD does not mean the device immediately fails. Instead, the device is delivered to the customer, only to fail later on, creating an unhappy customer and leading to expensive field service calls. These walking wounded devices may remain undetected and prompt repeated service calls, generating huge costs and frustration as one device after another fails. When electrostatic discharge is not controlled in a facility that handles ESD-sensitive devices, the results are higher product costs, lower product quality, and unhappy customers. Controlling ESD means just the opposite, and increased customer satisfaction is the name of the game. Let's stop for a moment to review the information we've covered so far. So now that you know what ESD is and what it can do to the electronic devices you handle, let's look at how you can prevent ESD damage at your work area. The most important fact you can learn about ESD control is that you are the most important part of ESD control. ESD is largely a people problem. No program to control ESD will succeed without your complete participation. Every company's approach to ESD control is different, but every procedure is designed to control ESD in one of these 5 ways. First, by minimizing charge buildup. Second, by neutralizing charges. Third, by draining off charges before they reach ESD-sensitive devices. Fourth, by minimizing field and discharge effects. And fifth, by protecting ESD-sensitive devices during handling at your workstation and while transporting product from one ESD-protected area to another. Let's look at each of these 5 ESD prevention strategies more closely. The place to start is by preventing static charges from building up in the first place. If you prevent charges from building on you and the objects at your workstation, then there'll be no static discharges. To begin with, know your work area's static-free boundaries. Inside this area, you are responsible for following and enforcing your company's procedures for static control. This should include not bringing unneeded static-generating items into this area, such as common plastics, styrofoam products, and other non-conductive materials. Non-conductive materials don't conduct electricity and are the worst offenders in generating and holding static charges and creating charge fields. Charge fields are created when a charged object, such as you or that styrofoam cup, is brought close to an ESD-sensitive device. In some cases, the device can become charged as far as 3 feet away, even if it's in a static protective bag. If the charged device comes into contact with a conductive item or a ground, the device can actually damage itself by discharging into that item. To keep these charges and fields from building up, your work area may have several static prevention items, including a special anti-static floor or floor coating. You may also be required to wear special shoes, usually with anti-static or static dissipative soles. But the best way to minimize static buildup is to eliminate as many of these unnecessary insulative materials from the workplace as possible. The worst non-conductive offenders include items such as vinyl binders, equipment covers, data diskettes, plastic document holders, safety glasses, post-it notes, plastic pins, bubble wrap, plastic light fixtures, plastic housings on equipment, and some clothing. In particular, plastic work travelers should not be allowed in static protective zones. Soldering irons, solder extractors, and testing instruments must also be specifically designed to be safe from generating charges. Don't bring unauthorized equipment into the protective zone. Also, avoid friction-producing activities, rubbing your hands together, lifting your arms, shifting your feet or legs, putting on or taking off your smock, combing your hair, eating, or touching static-causing materials. Wearing clothes made of cotton rather than wool or synthetic materials like polyester will also help prevent static, even if you're required to wear a special smock, which we'll talk about later. Also, avoid loose clothing or clothing that dangles down and may come into contact with ESD-sensitive devices. It's a good rule to always keep ESD-sensitive products at least 6 inches away from clothing. One common misconception is that high humidity will solve static problems, so you don't have to worry about these other static reducing measures. It won't. High humidity may reduce static generation below the level we can feel or see, but it may still be there in doses large enough to keep on destroying static-sensitive devices. The truth is, higher humidity only helps, while lower humidity will worsen ESD problems. Always be on the lookout for signs which show where ESD protective zones are in your work area. If you work in these zones, follow all the procedures your company has for minimizing ESD charges. This includes keeping people and objects who may produce ESD out of the protected area. Also, check and make sure all ESD-sensitive items that move through your area are properly labeled and that the labels are clearly visible. But don't assume that a device without an ESD warning label is ESD safe. Your supervisor can help if you are unsure if a device is ESD sensitive, but a good work habit is to treat all electronic parts and assemblies as if they are. It is easier to maintain a strict ESD prevention routine with every device you handle than to try and change your behavior depending on the component. Now, there are some cases where static generating objects must be in the work area, such as the plastic housing to a piece of equipment. You may be required to apply an anti-static solution at regular intervals to help control static buildup. But anti-static solutions may not be enough to control the static fields generated by some equipment. Because static fields produce a serious ESD threat, the second part of ESD control is to neutralize the charge these non-conductors create before they can damage an ESD-sensitive device. Remember, preventing damage involves more than just making sure that charged objects don't come into contact with ESD-sensitive devices. It also means eliminating static fields, which can charge the device itself. To make matters worse, a device may become charged even though it is several feet away from the static-producing item, such as this computer. As we mentioned before, the ESD-sensitive device will become charged from this field. Then when it comes into contact with a conductor, such as this grounded metal rack, the device will produce its own damaging ESD zap. Of course, the best way to prevent non-conductors from creating these charges and charge fields is not to allow them into the work area to begin with. But when this is not possible, like in the case of this computer, the solution is usually to neutralize the charge with an air ionizer. This machine blows ionized air into the work area, which helps to neutralize any positive or negative charges that accumulate on the non-conductor. Air ionization is not a cure-all for ESD control and should only be used as a last resort. Using an ionizer is also not a substitute for preventing static buildup in the first place, as we talked about earlier, or for not draining off static charges by using techniques like wrist straps, which we'll talk about next. But first, let's stop for a moment to review the information we've covered in this section. Now, since we can't completely prevent electrical charges from building up, the third part of ESD control is to drain off these charges before they reach ESD-sensitive devices. This strategy works only with conductors, those objects which conduct electrical current, like metal work tables and carts, and partial conductors, those objects which conduct electrical current, but not very well, like our bodies. Non-conductors, like that styrofoam cup we talked about, can't be discharged using this strategy. To drain off charges, all conductive surfaces and you need to be connected to a common grounding point. Metal and static dissipative work surfaces, storage racks, even chairs and equipment are connected to ground. The ground may be in the electrical ground wire of the building, the steel framework of the building itself, or a metal rod in the earth or the building's foundation. If a static discharge comes into contact with any of these metal surfaces, This connection safely channels the charge away from ESD-sensitive devices and neutralizes them into the earth. There are several methods used to drain off charges that you may carry into an ESD-protected area or that you may generate while working. The most common are the wrist strap and heel strap. To operate effectively, the wrist strap must be worn snugly against bare skin and should be attached securely to a ground wire with a current-limiting resistor and some form of quick disconnect device. The current-limiting resistor is also very important. It protects you if you touch an electrically live circuit. If either of these connections are faulty, the wrist strap may fail to do its job. This is why your wrist strap should be tested regularly. Your company will tell you where and how often you should do this. Be sure and wiggle the wrist strap when testing to check for intermittent failures. In some cases, your wrist strap may be attached to a continuous monitoring system. This will tell you immediately if your wrist strap stops working properly. If you experience any problem with your wrist strap, especially the current-limiting resistor, contact your supervisor immediately. There are a variety of different heel straps in use, but they all are designed to connect your sock to a conductive floor or mat. The strap is placed on each shoe so that one end is in contact with your sock and the other end is in contact with the floor. There is enough moisture in your sock to provide a complete electrical connection from your body to ground. Like the wrist strap, it is important to test your heel strap at regular intervals. Conductive shoes are another effective way of passing charges harmlessly through to ground. Like heel straps, they provide a conductive path from your body through your sock and shoe to a grounded floor surface. Special conductive smocks are used to cover static-producing clothing and drain any charges to ground. The smock should be completely buttoned to ensure that no part of your clothing is exposed. Your smock sleeves should not be rolled up to expose any clothing. To drain any charge on the smock, some portion should be in contact with your skin or a wire should connect the smock to your wrist strap. As we mentioned earlier, you should also avoid loose clothing that can come in contact with ESD-sensitive devices. The fourth ESD prevention strategy is to minimize the effect a discharge may have on an ESD-sensitive device and to protect devices from static fields. If an ESD-sensitive device does become charged, it is important that it not be allowed to discharge rapidly with an ESD zap that could damage it. The material used to eliminate these harmful discharges is called static dissipative and is found in work surfaces, floors, and various containers. These materials conduct electricity, but slowly enough to not damage the component. A static dissipative work surface is most commonly used in this part of ESD control. If an ESD-sensitive device becomes charged and is placed on this surface, the surface will absorb the discharge at a rate which will not harm the ESD-sensitive components. The slow dissipation of the charge is why metal work surfaces are not an effective part of ESD control. Metals are good conductors which will cause the electrostatic discharge to happen too quickly. A quick discharge may damage the device. Another application of the static dissipative surface is the conductive container. Place an ESD-sensitive device in one of these bags or boxes. If you approach the device carrying a charge or the container is carried through a static field, the container will provide a protective cage around the device. This leads to the fifth and final element in a complete ESD strategy: protecting ESD-sensitive devices during handling at your workstation and transport from one ESD-protected area to another. The first part of this protection is to use all of the previous steps to guard the device from static fields and discharges while being handled at your workstation. The grounded workstation, your wrist and heel straps, static dissipative mats and work surfaces should work together to provide an envelope of ESD safety. In addition, try to follow these additional handling rules. Always touch the conductive or dissipative work surface or the corner of the ESD protective packaging before picking up a device. This way, any charge you may have picked up can be completely discharged before you touch the device. Never make unnecessary contact with device leads or contacts. The less contact, the better. You can't zap a device unless you come near it or touch it. Keep the device with its pins down on a static dissipative surface. This way, all the component leads are more protected. Don't slide the device over any surface. Sliding creates friction, which can create static charge. Handle ICs by the body, not the leads. The leads are the most conductive pathway to damage. The body is less of a pathway. Avoid rapid friction-producing activities while handling the device. The only movements you should be making while handling the device are those which are absolutely needed to complete your task. Overall, handling of ESD-sensitive devices should be minimized at all times. When moving ESD-sensitive devices from one safe handling area to another, follow these rules. Always use clean containers that are the proper size for the device and clearly marked for ESD-sensitive items. Make sure the device is completely inside the container and the container is closed. Don't leave the device next to or on top of the container. Use only ESD-sensitive approved tape to label the container. Don't place plastic pocket travelers on or near the container. Use only push carts which are designed for ESD-sensitive devices. Check to see that the cart is grounded and that all the shelves have complete conductive contact with the frame. Let's stop once again to review the information we've covered in this last section. ESD can be a difficult condition to prevent because it often can't be seen or felt. Only through constant attention to the strategies outlined in this video can ESD be prevented in your workplace. Remember that each of you are the captains of the ship, and all the wrist straps and fancy workstations available are no more effective than the person who uses them. Your constant discipline in wearing the appropriate equipment, following the proper handling, storing, and transport procedures, and reporting any problems or ESD hazards immediately will make the difference between quality and ESD damage. Only you can make certain that lightning doesn't strike at your workstation.